Hello, Honors Geometry. We have lesson 11.1, and we are talking about circumference and arc length here. So as we work through this, I want you to, we talked earlier in chapter 10 about referring to the crust of the pizza. We talked about degrees for the pizza, but now we are going to talk about the actual length of the crust today. So circumference is the distance around a circle. Okay, so the circumference of a circle is the distance around the circle. For all circles, the I think that's supposed to say rotation of the circumference C. Oh, ratio. No, it's not rotation. Ratio. The ratio of the circumference C to the diameter D is the same. This ratio is C over D equals pi. Okay, so pi is an irrational number. You've hopefully seen that before. And as we look at this, that's going to create our circumference equation for a circle. So the circumference of a circle is 2 pi r. Obviously 2 pi times the radius, and we all know that 2 times the radius is the diameter, so you also might want to use pi times d. So you can use either of those two. You'll see me mostly use the 2 pi r, but just know they can be interchanged here. Okay, so as we move on, it says find each indicated measure. So we want to find the circumference of a circle with a radius of 9 centimeters. So circumference is 2 pi r. Okay, so as we do this circumference, in this formula, you want to look at what's given to you and replace it. So we are given that the radius is 9 centimeters. So we have 2 pi times 9. Okay, so there's two different ways that you can write this. If it asks for the exact measure, you are going to leave it in pi form. So in multiplication, it can be in any order, and pi technically would represent kind of like a variable. So 2 times 9, we have 18 pi. Whoops. If it asked for the exact answer, you would leave it as 18 pi. Otherwise, you could plug in 3.14, or you could plug in the pi button on your calculator. So you take 18 times pi, which is roughly 56.5 centimeters. And I want you to notice that circumference is a length. It's not an area. So when you label it, you are labeling it as centimeters. We're not squaring that at all. Okay, for the next one, you're using that same equation of circumference equals 2 pi r. Okay, and this time they want us to find the radius if the circumference is 26 meters. So what you're going to do is you're going to replace what's given. So 26 is the circumference, and we have 2 pi, and we are multiplying by r. R is what we do not know. Okay, so as you are trying to get r by itself, hopefully you see that you are multiplying by 2 pi. So go ahead and divide by 2 pi. Now something interesting happens here. If you have a calculator in front of you, I want you to go ahead and divide 26 by 2 pi. Okay. When you are looking at this, let me grab my calculator here. If you take 26 divided by 2, and by the way, the pi button is right here, your calculator is not smart enough to keep that pi in the denominator, so it's going to give you a much bigger number than what we want it to be. So if you look at this, what ends up happening is we want to take 26 and we want to divide by 2 pi, both of them in the denominator. So you have to put parentheses. This will not be the only time that you see this happen today. But if 2 pi is in the denominator, you need to notice the difference between plugging that in your calculator. So it should have been 4.1, we'll just say 4.14. So the radius is 4.14. 14. And this was measured in meters. Okay, now we have what is called an arc length. Okay, so we had arc measure before, and that was talking about the degree. We are now going to talk about arc length, and this is the portion, okay, the portion of the circumference of the circle. You can use the measure of the arc in degrees to find the length in linear units, okay? So we are going to use proportions to solve for this. So I want you to set up, you'll see underneath example 1, it says arc length. In that little space down below, I want you to go ahead and put 2 ratios. Okay, we're going to use this a lot. So the left-hand side is going to be your length, and the right-hand side is going to be your degree. Now to set up ratios, the total is always on the bottom, okay? The total length of a circle is your circumference, okay? So you will see this either as C or you will see it as 2 pi r, okay? That's the total distance around. Now your arc length is the part of the pizza. So I want you to think about the bottom is your whole pizza crust, okay? And then the top is just your piece of pizza crust, okay? Now, when you are looking at your degrees, you have to think about how many total degrees are in a circle. There are 360 degrees, okay? And then whatever measure your central angle is, okay, that's the degree measure of your arc. Okay, so this is your arc degree measure. Okay, so make sure that you have this written down. Okay, so now we want to figure out, now I know that mine are in color. You don't have to see this. It says find the arc length. So we want the length of just this piece of crust here. Okay, so crust AB. So let's just say that you're going to have a slice of pizza. Okay. Okay, so for the slice of pizza, we are going to set up our proportion here. And we are going to talk about what's given. Now, I always set my proportion up where we have 360 in the bottom right-hand corner. The whole circle will always have 360 degrees, so you can always start by having this proportion, okay? Now, any degrees that we are given that the slice of pizza is 60 degrees, okay? So we're gonna always take the degree out of 360. Now we want the arc length of part of the circle, okay? So we want to know what that is. And since we are given 8 is the radius, we can plug that into 2 pi r. Okay, so now what we're going to do is we're going to cross multiply. Okay, so we have 2 pi r times 60 equals 360 times x. So I'm going to plug in, oops, I don't know why I have r here. R is 8. Okay, look at what I did here. I wrote r. Make sure that you put this as 8. Okay, we don't want it. I looked and there's too many variables. We just want this x here. Okay, so plug in your calculator. 2 pi times 8 times 60. So 2 pi times 8 times 60. Okay, so you're going to get this large number. Okay. So we have 301593 equals 360x. Okay. So go ahead and divide by 360 degrees. And you should get 8.38. And this was measured in centimeters. So the crust of slice AB has a length of 8.38 centimeters. Okay, notice in the next one, okay, we have that we want to find the circumference. So once again, start your proportion with a 360 in the bottom right-hand corner. Okay, if you look at our picture, we are given 40 degrees. So you're writing 40 out of 360. Now notice that we are given that this crust right here is 4.19. This is not the whole, this is the slice of pizza. So that is going to go on top of the length on the left-hand side. What we are trying to find is the whole circumference. Now, if you use 2 pi r, that is okay, but it does make it trickier in the end. We are trying to find the whole circumference. So notice that it makes it a lot easier if we just put our unknown in that bottom left-hand corner, because once we find c, that'll be exactly what we're trying to find. Okay, so cross multiply. So we end up, I just plugged this all in at once. So cross multiply 4.19 times 360, hit enter and divide it by 40. You get a circumference of 37.71. It's circumference, so just inches. Okay, the last one here. Okay, as we look at this, you're going to set up your proportion. Go ahead and put your 360 in the bottom right-hand corner. I want you to notice in the picture that there are no degree measures, okay? When you have this little m in front, that means that they want the degree. We don't know that. If you go up here where it says arc AB, notice there was no m in front. That wanted an actual length, okay? So down here, when they have that m, we know that we're trying to find part of the degrees, not the whole thing, obviously, because we always know that's 360. Okay, so as you go to the next part, we have that part of the crust is 44 meters, okay? So this crust has a length of 44 meters, okay? This 15.28 is our radius, and our radius is used in the circumference formula. So 2 pi, and then our radius, which is 15.28. Okay, when we cross multiply, okay, oops, don't put the label in there. I put m in there for meters. Don't do that. It looks like two variables here now. So you're going to cross multiply and do 44 times 360. So 44 times 360. Okay, now we are going to divide that. If you look at this piece, we are going to divide by 2 pi 15.28. Now remember, in our first example, we had to divide by the pi's in parentheses. So 2 pi r, which is 15.28. So just make sure that that is in parentheses. Okay, so you get 164, and then the 8 makes the 9 a 10, so 165. So x equals 165, and this was measured in meters. Oops, it is not meters. We were trying to find a degree. Okay, so 165 degrees. Okay, let's move on to the next page. We have a couple word problems here. So, example 3, the dimensions of a car tire are shown. To the nearest foot, how far does the tire travel when it makes 15 revolutions? Okay. Well, what you want to look at is you want to know the distance around the entire tire. Okay. That'll be the distance that one revolution makes. Okay. So number 1, find the circumference. So C equals 2 pi r, or you could even use pi times d. Okay, so when you add all these up, this will be the diameter. Okay, so let's go ahead and plug that in. The circumference, when you add all those together, it's 26. So pi times 26 is 26 pi. Okay, so this is just for one revolution. Okay, we want to figure out what's the total distance in 15 revolutions. So what we're going to do is we're going to take this 26 pi and multiply by 15. So you can go ahead and plug that in on your calculator. You get 102 feet. Okay. The curves at the end of a track shown are 180-degree arcs of a circle. The radius of the area of the runner on the red path is 36.8 meters. So that's the radius. About how far does the runner travel to go once around the track? Okay, so as you look at this, we want to just look at the red arc. So we're just paying attention to the 36.8. If you look at the curved part of this track, when you put two halves together, you get a full circle. So the circumference is 2 pi times the radius, which is 36.8. And you get 231.2 meters. Okay, now you have the straight part of a track, and you've got two of them. So for the straight part, you are going to take 2 times 84.39. That is 168.78. So now we're going to take our curved part and add it to our straight part. And that will give us basically a perimeter of 400 meters, which makes sense because one time around the track, they call that the 400. Okay, this last one here, when you are looking at this, you have to find, you have 3 straight parts here. You are finding the perimeter around the whole piece. So to find the perimeter, we have 3 parts that are 5, and then you have 3 curved parts. Okay, what you want to do is if you look at 120 and you multiply by 3 of those parts, okay, 120 times 3 gives you a whole. Okay, because that's 360 degrees. So what you're going to do is you want to find the circumference of one whole circle. Okay, so as you are looking at this, if you look at this part here, okay, the radius is 2.5. Okay, so we've got a circumference where it's 2 pi times 2.5. Okay, and then you are going to add that to 15, and you should get roughly 30.1